day to all the dear students. Chapter number 11, Rectilinear Figures. This is part 1 of this chapter, and here I have explained you the different quadrilaterals properties. And exercise 11a, the first question, unknown angles we have to find out. Chapter 11, Rectilinear Figures. We study about some figures here. I have drawn some figures. Now this figure, it has 3 sides and 3 angles, so we call it triangle. Then this figure has 5 sides and 5 angles, so we call it pentagon. Then this figure has 4 sides and 4 angles, so it is known as quadrilateral. Qua means 4 and lateral means it is drawn on a plane surface, so quadrilateral. 4 sides, 4 angles. And this figure has 6 sides and 6 angles, so we call it hexagon. So here students, in these 4 figures, these are the plane figures which can be drawn on a plane surface and with the straight lines. All the figures are drawn using straight lines, and also they all are closed figures, means they are not open figures. So this type of figures, so these are the 4 figures which are drawn on a plane surface with straight lines, and they all are closed figures. And the examples are triangle, quadrilateral, pentagon and hexagon. So these are called rectilinear figures. Rectilinear means straight line figures. Now this chapter mainly we are going to study about quadrilateral, means any 4-sided figure, and if we join the opposite angles with a straight line, so they are known as diagonals. So this is the quadrilateral with 2 diagonals and 4 sides and 4 angles. Now here I have drawn a flow chart of quadrilaterals. Here we are going to study about different types of quadrilaterals. So there are main 3 types of quadrilateral. First is parallelogram, second is kite, and third is trapezium. Then parallelogram, the word only we can say that opposite sides are parallel, means in a quadrilateral there are 4 sides, so in a parallelogram 2 pairs of opposite sides are parallel. And in parallelogram there are some other types, kind rectangle and rhombus. Rectangle having opposite sides are parallel and all sides of all angles are of 90 degree. Rhombus, all sides are equal. And square, that is one type of rectangle whose all sides are equal and all angles are also equal and 90 degree. Second is kite. From the name you can understand, kite means it will be of kite shape. Means 2-sided smaller and 2 big sides. Trapezium. Trapezium means only one pair of the side is parallel and the other sides are not parallel. And isosceles trapezium means one pair of the side is parallel and the other side which is not parallel is equal. So that is called isosceles trapezium. So now students, in a short I explained you what is parallelogram, kite, trapezium and other types. Now with the figure we will learn the properties of this quadrilaterals. Here we are going to learn about properties of parallelogram. So you can see students the figure I have drawn of parallelogram here. This is a quadrilateral A, B, C, D, and these are the diagonals. Now here in this figure opposite sides are parallel. means AB parallel to CD and AD parallel to BC, means both two sides of two pairs of the opposite sides are parallel, then we say it is a parallelogram. Now both the opposite sides are equal. So first of all, I would like to write first property, that AB parallel to CD. This is the parallel symbol. Also AD parallel to BC. So this is our first property of parallelogram. Now second, opposite sides are also equal. So here AB is equal to CD, means whatever the measure of AB is same as measure of CD, and BC is equal to AD, means opposite sides are equal also. Now the third property is opposite sides are both parallel and equal. Now we come on to angles. So here in parallelogram, opposite angles are also equal. Like angle A is equal to angle C, angle B is equal to angle D. This is the third property of angles. Now the fourth property is for diagonals. Diagonals are AC and BD here. Diagonals bisect each other. So here bisect means, suppose I write O point, that is the intersecting point of AC and BD. So we can say that OA is equal to OC and OB is equal to OD. It means it bisect each other. So the fourth point I am writing here, OA is equal to OC and OB is equal to OD. Again, diagonal bisect each other, and also that it bisect the parallelogram also. The fifth point I am writing, that these diagonals are like that ABD is same as CBD, means these two triangles are congruent. Similarly, ADC is similar to ABC, or you can say congruent, means they can be, this diagonal can divide our parallelogram in two congruent triangles. So I can write triangle ABD is congruent to triangle CBD, and also another triangle formed is triangle ADC is congruent to triangle ABC. Likewise, these are the main 5 properties of parallelogram. So you have to understand, students, and remember this to solve our problems and also prove that type of questions. Now, after the parallelograms property, we will learn about rectangle, properties of rectangle. So you can see the figure here, everybody, properties of rectangle. This is rectangle ABCD drawn here, and the first property we learn about is that first one is about parallel sides. The opposite sides are parallel. Why? Because we all know that rectangle is one type of parallelogram. So how we can say that? From that property only, that it is one kind of parallelogram, the opposite sides are parallel. So I write AB parallel to CD and BC parallel to AD. This is the first property. Secondly, we can write the opposite sides are equal, means AB is equal to CD and BC is equal to AD. So always in rectangle, the opposite sides are equal. Then you can see in the figure all angles are of 90 degree and they are all equal. So angle A is equal to angle B is equal to angle C is equal to D. All are 90 degrees and they all are equal in measure. Now we come to fourth point, that is about diagonals. So here AC and BD are two diagonals. So diagonals are always equal in measure, means AC is equal to BD. Always you have to remember this. The diagonals of rectangle are always equal in measure. Then we can say that they do not. Some students might have that impression in the mind that here they meet at 90 degree or they bisect at 90 degree. But it is wrong. Here in rectangle, the diagonals do not intersect at 90 degree. Only AC is equal to BD. So these are the main four properties of rectangle we have seen now. Now we have seen parallelogram and rectangle. Now the other type is square. So we will see properties of a square. So here you can see a square is drawn. So I write here properties of square. The square ABCD. Here you can see a square ABCD is drawn. The first property is from the table only. You can see it is one type of parallelogram, means the opposite sides are parallel. Means I have written the first property, AB parallel to CD and BC parallel to AD. Now second one, the AB, all the sides are equal in measure. You can see in a square. So I can write AB is equal to BC is equal to CD is equal to AD. All four sides are equal in measure. The third point is all the four angles A, B, C, D are of 90 degree and they all are equal in measure. So the third point is very clear now. The fourth point is about diagonals. So here in square, diagonals are equal in measure and they cut each other at right angles. It means here it will be 90 degree and I can write AC is equal to BD. And also it makes angle AOB and BOC, COD, AOD. All four angles will be of 90 degree because they all are angle round the point. They are forming vertically opposite angles. It means we can say that AC perpendicular to BD means the diagonals are at 90 degrees, or we can say they are perpendicular. Means these are the four main properties of square. The fourth one is very important. The diagonals are equal in measure and they cut each other at 90 degree. Now we have studied about properties of parallelogram, rectangle and rhombus. Not rhombus, square. Now next we are going to take the properties of rhombus. So here in the figure you can see rhombus is drawn. A, B, C, D. This is the rhombus. Now from that table only we can understand it is one type of parallelogram. Means the opposite sides are parallel. So the first property is AB parallel to CD and BC parallel to AD. So this is our first property in which the opposite sides are parallel to each other. Now second property is all sides are equal in measure in rhombus. So AB is equal to BC is equal to CD is equal to AD. All four sides are equal in measure. Then next is about angles. So angles, opposite angles are equal in rhombus. So we can write angle A is equal to angle C, angle B is equal to angle D. All four angles are not equal, but the opposite are equal in nature. And diagonals ACBD, they bisect each other at 90 degree. Means here it makes 90 degree angle here, and they bisect each other, means OA is equal to OC and OB is equal to OD. So the next we can write OA is equal to OC, OB is equal to OD, and also they are perpendicular because they make 90 degree. So AC perpendicular to BD. This is the diagonal property of rhombus. Now the next one is that this diagonal bisect the angles also. It means this part is equal to this here, and this part is equal to this. So according to diagonals, we can say that it bisect each other here. So the last property, number 5, I am writing that angle BAO is equal to angle DAO, and likewise opposite also equal. In other way, I can write diagonals bisects angles. So you can understand clearly that all the angles are bisected. Students, in last we have seen properties of rhombus. Now it comes properties of trapezium. You can see our chart, in that trapezium will be there. So here now this is the figure of trapezium ABCD, and you can see that opposite sides are parallel, means only one pair of the side is parallel. These are the non-parallel sides. So in this trapezium, one property is very important, that is AB parallel to CD. That is the main property. How we recognize trapezium, that only one pair of the sides is parallel, and these are the non-parallel sides of trapezium. So likewise, this is very simple, you can understand. Now we will see isosceles trapezium. So now I change here. Trapezium figure will be same, but instead of trapezium we will learn about isosceles trapezium. So here we change our name from trapezium to isosceles trapezium. So it will be isosceles trapezium. So in isosceles trapezium, according to trapezium, the one pair of the side is parallel, and the non-parallel sides AD and BC are equal in measure. These two are equal. Also here angle A is equal to angle B, and angle C is equal to angle D likewise. So here I write first property already written in isosceles trapezium. Now the second is that non-parallel sides are equal. It means AD is equal to BC. Third property is about angles, that angle A is equal to angle B. On the base, the two angles are equal, and the other two angles C is equal to angle D. So this is the angle property we have seen, property number 3. Now the fourth one is diagonals. We have to draw here diagonals. So I draw here AD, AC and BD. So these are the diagonals here, and they are equal in measure. So I write AC is equal to BD. Both the diagonals are equal in isosceles trapezium. So here we recall again all the properties. Also, this is the intersecting point here O, where the diagonals intersect. So what we have to say, OA is equal to OB. You can see these are two bigger parts and these are two smaller parts. So the fifth property we can write is OA is equal to OB and OC is equal to OD. These two are the smaller parts. So they are equal in measure. So now again, first is for isosceles trapezium. One pair of the sides is parallel. The non-parallel sides are equal, that is AD is equal to BC. Then the two angles which are on base are equal and the other two angles are also equal. Then AC is equal to BD, means the diagonals are equal. And where the diagonal intersect, from there OA is equal to OB and OC is equal to OD. So these are the properties of isosceles trapezium. Here you can see and understand. Okay, now the last shape remain, that is kite here. So now we will see properties of kite. Here the figure of kite is already drawn. You can see clearly this is the kite shape figure. Now I have drawn A, B, C, D kite. So first of all, the first property we write. So here no sides are parallel to each other, but we can write which two sides are equal. So from the figure only you can see AB is equal to BC and AD is equal to CD. Means lower two sides are equal and upper two sides are equal. So I write here AB is equal to BC and CD is equal to AD. Means the adjacent two sides are equal in measure. The next is that the diagonals, you can see the diagonals are intersecting at 90 degree. So they are perpendicular to each other. So I can write AC perpendicular to BD. This is about the diagonals. Diagonals are perpendicular to each other. They form 90 degree here. Also about the angles we say, so angle A is equal to angle C here. So the third property is angle A is equal to angle C. We can see clearly that this angle is not equal to this. This is somewhat narrow and this is broad angle. So these two angles are not equal, but the side angles are equal in measure. Then the fourth property will about these two parts OA and OC. They are equal in measure. So I write OA is equal to OC. Why? Because you can say angles are equal. They are perpendicular, means from O to A and O to C distance is equal here. And next, the fifth property here we say that diagonal BD bisect B as well as D. But you can see this BD diagonal will bisect the angle B and angle D. So I can write diagonal BD bisects angle B and angle D. Both the angles bisected by that diagonal BD here. Then the sixth property, that diagonal BD, this diagonal only will divides the kite in two congruent triangles. You can see ABD is same as BCD. So I can write BD divides kite in two congruent triangles. So that way you can say ABD congruent to BBC, or any way you can write here two triangles are congruent. So I write here triangle ABD congruent to triangle CBD. So likewise you can see these are the properties of kite here. You have to remember. Now let us start exercise 11a. Calculate the angles marked. So I have taken second figure here, which is rectangle PQRS. In this rectangle, the diagonals are drawn and there is formed an angle of 120 degree. Also, in this corner, that angle R, it is divided as angle A and B. So we want to find the marked angles, means angle A and B values. So for that, let us start our solution. First of all, we all know that these are the two straight lines, so it forms vertically opposite angles. So if 120, this is also 120. Now students, we all have studied our properties of rectangles, in which we have studied that the diagonals are equal in measure, means PR is equal to SQ. So we can say these parts, which are the half of the diagonals, are also equal here. So if this is B, so this is the isosceles triangle formed now. Two sides are equal. So opposite to this B. So opposite to this also it will be marked as B. So in this triangle, I can say by using angle sum property, value of B can be found. So now I write here first of all that let us take here O, so that we can write something about it. You can make changes accordingly, but you have to show it in the figure that which changes you are doing. Okay, so now I am writing angle SOR is equal to 120 degree. First of all, why? Because they are vertically opposite angles. So this you can see VOA means vertically opposite angles. Now we can write here PR is equal to SQ. Therefore OS is equal to OR. They are the half of PR and SQ. So they are also equal. So we can write in triangle SOR, this upper triangle SOR, that is by angle sum property. I can write by angle sum property. What is our angle sum property? The sum of the three angles of a triangle is always 180 degree. So angle B plus 120 degree is equal to 180 degree. So now using, I calculate is 2B plus 120 degree is equal to 180 degree. Therefore 2B is equal to 180 as it is here, and this 120 taking on right hand side, so it become minus. So therefore 2B is equal to 60 degree and angle B is equal to 30 degree by dividing it with 2. So we get our first answer, that B value is 30 degree here. Now let us find our angle A also, so that we can calculate here. Now see the figure again, students. So in the figure here, this is our angle A and we want to find A. For that, this is a straight line SQ. So how this angle will be? They are the forming linear pairs. So I can write this is of 60 degree angle. This one ROQ angle is of 60 degree. And again that PR is equal to SQ. So I can show this, that this OR part is same as this OQ part. Half of them are equal. So likewise I write in first of all I write angle ROQ is equal to 60 degree. Why? Because it forms linear pair. Okay. Then next I write in triangle ROQ. So if these two are equal, so here we can write this is A, this is also A. By angle sum property, here A plus 60 degree is equal to 180 degree using angle sum property. So now what is A plus A? It becomes 2A plus 60 degree is equal to 180 degree. So 2A is equal to 180 minus 60 will become 120 degree. So A is equal to 60 degree. Or in other way, I show you students how you can find this A. Now first of all, you have to see here B is found as 30 degree, and in the figure you can see that this B plus A is forming 90 degree, no? Because rectangle all angles are 90 degree. So A plus B 90 degree. So after this step you can directly write that after you found B value 30 degree, you can directly write A plus B is equal to 90 degree. So A plus B is equal to 90 degree. Therefore, A is equal to 90 minus 30, 60 degree. So either this much you can solve, or you can show the right hand side part what I have shown. Here you already find A and B values. So this part if you do not show, it is okay. Okay, so this way our calculations you have to show in your answer properly. Now let us start question 1. Calculate the angles. Number 4. This is rhombus given to us. So you can understand nicely about our rhombus properties. Now here you have to find x and y value, students, and only one angle 34 degrees given to us. Now the property of diagonals about the rhombus is that diagonal bisect each other at 90 degree in rhombus. Means this angle is 90 degree. So now in PLQ triangle we can use our angle sum property to get our value x. So first of all from the figure only you have to think that how you will calculate. So let us start writing in triangle PLQ. This is angle L given to us. So in triangle PLQ by angle sum property we can say 34 degree plus 90 degree plus x is equal to 180 degree. So here I have not written this about 90 degree, but in the figure I have shown it clearly so that it will okay if you do not write it. Okay, so x is equal to 180 minus this 90 plus 34 is 124. So now subtraction is 56 degrees. So first answer x value we found is 56 degree. Now we want to find value of y also. So that is also simple, students. I explained you this is 90, so this angle will also be of 90 degree because this is a straight line, and straight line two angles are formed. One more thing, that this is the diagonal, and in rhombus diagonal bisect the angles also. It means 34 degree here, so here also it makes 34 degree. So you can see that this PLS and PLQ both are the congruent triangles formed. So whatever the value of x, the same will be the value of y. So we can write similarly in triangle PLS by angle sum property 34 plus y plus 90 is equal to 180 degree, and y is equal to 180 degree minus 90 plus 34 124 degree. Therefore y is equal to 56 degree. So likewise we get our both the answers, x value 56 and y value also 56 degrees. So this is the answers we found using our properties. So you all have to remember the properties throughout the chapter. Okay, question number 1. Calculate number 6 here. There is a square given CDEF. Square drawn here. Now in this square we are given FD, a diagonal, but EN is not a diagonal. So we will find value of x accordingly. Here is given 38 degree angle. You can see in the figure 38 degree and x. So we want to find x value. For that, first of all, here they form a vertically opposite angle. So I write here also 38 degree. This is the smaller angle. You can see 38 degree. Not visible. So I rewrite again here 38 degree like this. Okay. Now the next is, we know that FD is a diagonal given. So in square all angles are of 90 degree, but this is the diagonal. So this is makes here 45 degree and here also 45 degree. So similarly here also it makes alternate angles and this is also 45 degree angle. Now we have to find this smaller angle. You can see in the figure, this is the M and D angle, which I will find out. So now let us start our solution here. For that I write first of all angle NMD is equal to 38 degree VOA. It means vertically opposite angle. Then I write here about diagonal property, that angle F is equal to angle D is equal to 90 degree. We all know that square all the angles are of 90 degrees. Then we can write FD, the diagonal. This is the diagonal and it bisects the angle. So angle EFD is equal to angle CDM. These two are forming alternate angles. So they are equal, is equal to 45 degree, 45 degree. And now in triangle M and D, this M and D, the smaller triangle, we use angle sum property. By angle sum property, we write 38 degree plus 45 degree plus angle N is equal to 180 degree. Then we calculate accordingly here. Angle N is equal to 180 degree minus 45 plus 38 is 83 degree. And subtraction of this is 97 degree. So this is not our angle we want to find out. We want to find out the another angle, which is this x1. So this angle is in the triangle. This one I found here, that is 97 degree. Now I'll find x. So that is forming again linear pair. So x will be 180 degree minus 97, which is again 83 degree. So x value here they asked to find out, and we found x value as 83 degree as our solution. So this is our question number 6, in which we are given square figure and the answer is 83 degree. Exercise 11A, question number 8, that is kite given. There is no name given, but clearly you can see this is kite here. It is drawn horizontally. Now in the figure, students, you are given this angle 39 degree and this angle 74 degree. Also angle A and B, these two sides are equal and these two sides are equal. One more thing I have taken here, that the diagonals are intersecting at 90 degrees. So I wrote there 90 symbol. Now we have to start our calculation by taking in this upper triangle. For that I write here O, for that you can see. So in that triangle we can write, no need to write here anything because you can see nothing is written. Directly we will write here by angle sum property. In this smaller triangle, this is also 90. So A plus 39 degree plus 90 degree is equal to 180 degree. Okay. So next is A as it is. The sum of this is 129 degree. So we get value of A is equal to 180 degree minus 129 degree. That will be 51 degree. So A value we found here as 51 degree as our answer. Now we calculate B value, which is here drawn. For that we have to just see the figure first. In the figure, this is these two sides are equal, means here is 74, so this will also become 74. And one more thing, that this triangle, now you can see this triangle. This is A is known to us, 51, 74 is there, 39 is there. So we can find B value accordingly. So I write here that angle I write 51. So in the bracket I write 51 plus 74. That is the whole angle, 74 plus 51 plus 39 degree plus B is equal to 180 degree. In this triangle I have taken angle sum property. Then the sum of this all is 4 plus 1, 164 plus B is equal to 180 degree. So B value is equal to 180 degree minus 164 degree. That will be 16 degree as answer. So our second answer, value of B is 16 degree, and the first answer, value of A, is 51 degree. So then this kite, you can see first of all we have used 90 degree, the intersection of two diagonals. Then we have taken this smaller triangle first, angle sum property, to get our value of A. And then in this whole triangle I have used isosceles property, that two sides are equal, opposite angles are also equal, and accordingly I found B value also. Exercise 11A, question number 9. From the figure we have to say which figure it is, because in the question we are not given the shape, but here you can say the opposite, the one pair of the side parallel and the non-parallel sides are equal. It means it is isosceles trapezium. Isosceles trapezium. So we will think about the properties of isosceles trapezium to solve this question. Now, first of all, in this isosceles trapezium, diagonals are equal in measure. It means this part equal to this part here. So you can say this is 34 angle. So this is also 34. Why? Because this equals this here. That is why. So we can write in this triangle angle sum property. So write by angle sum property. I can write that 34 degree plus 34 degree plus A is equal to 180 degree. Therefore, A is equal to 180 degree minus 68, that is equal to 112 degree. So our A answer here found by calculation as 112 degree. Now the first answer we have already found, A is equal to 112 degree. Now we have to calculate B. In the figure you can see your B is here. So for that you have to think. Now student, here is 34. So this angle also must be 34. Why? Because they are forming alternate angles. These two sides are parallel, no? So they are forming alternate angles. Now here you can see that these we have formed alternate angles, and these are forming vertically opposite angles. So A we found 112. So this is also 112 degree because they form vertically opposite angles. Also now this part is equal to this part. So the opposite angles are also equal. So this is also 34 degree here. So now in this triangle, one more thing. This angle, this whole angle is equal to this whole angle. It means here is 34, here is 34, here is 72. So it will be 72 degree here also in the figure. Now we take this whole triangle to get our value B, because we have this whole angle 34 here and B here. So all these things I have shown in the figure only, because there are no names given. So how do we write which angle? But I explain you again. After alternate angles 34 34, these are two vertically opposite angles and they are equal in measure. Then these two sides are also equal, so the opposite angles are equal. Also, this angle is equal to this angle according to our property of isosceles trapezium. So here 72, here 72, 34, 34. So write by angle sum property, I can say B plus this 34 34 will become 68. So I write 68 plus 72 is equal to 180 degree. Now sum of these two is, I write 180 minus 68 plus 72, that is 140 degree. So B value is equal to 40 degree. By subtraction we found. So this is our second answer, that B value is we found as 40 degree. So here students, how to find marked angle using our different shapes properties. Now different quadrilateral properties we are using here to get our unknown angle. So this is question number 9 solution, both A and B values found.